Hi student, welcome back to Fundamental Thermodynamics LMD. Today we are going to discuss another subtopics which is phase change of pure substances. In this video, we will refer to substance water. This is because everybody knows what is water as well as the boiling point and ice point of water. The objective for this subtopic is to discuss the physics of phase change processes. Before we go to the phase change processes, it's best for us to know the types of phases. Okay, here we have 5 types of phases. We will start with compressed liquid, also known as subcooled liquid, which is a substance that is not about to vaporize. Okay, and then we have saturated liquid, okay, which is defined as a liquid that is about to vaporize. And then we have the saturated liquid vapor mixture, which is the state at which the liquid and vapor phase coexist in equilibrium. And then we have the saturated vapor, a vapor that is about to condense. And then also we have superheated vapor, a vapor that is not about to condense, or also known as not a saturated vapor. Alright, now let's discuss the phase change process. Okay, so here let's say we consider a piston cylinder containing water at 1 atm pressure and 20 degrees Celsius. Okay, so at this state, water exists in the liquid phase, also known as saturated liquid. Okay, as the temperature increases, the liquid water will expand slightly, and so its specific volume will increase. The piston will move slightly. Okay, however, the pressure will still maintain or remain at 1 atm since the process depends on the outside barometric pressure and the weight of the piston, which both are constant. So that means at this state, the water is still a compressed liquid. Okay, going to the state 2. Okay, you can see here the pressure is still maintained at 1 atm, but the temperature already rises to 100 degrees Celsius, okay, which is also the boiling point of water. Okay, so since heat is continuously being applied to our system, okay, so what will happen is the temperature increase to 100 degrees Celsius, and any heat addition will cause liquid to vaporize. So the phase change from liquid to vapor is about to take place. Alright, so that is why at state 2, this state is also known as saturated liquid. Okay, or we go back to the definition, a liquid that is about to vaporize. Okay, and then going towards our state 3, okay, inside our slide here, you can see inside our state 3, our phase already separated into 2. On the top, we have the saturated vapor, okay, and at the bottom, we have the saturated liquid. But the pressure and temperature still remain the same, 1 atm and 100 degrees Celsius. Okay, so as more heat is transferred, part of the saturated liquid vaporizes and it will become saturated liquid vapor mixture. Since a liquid and vapor phases coexist in equilibrium at this state. Okay, moving to state 4, you can see here, again, the pressure is still remain the same at 1 atm and the temperature is at 100 degrees Celsius. Okay. Okay, when the last drop of liquid vaporize, okay, that is when our state 4 is known as saturated vapor. But at this state, any heat loss will result in a vapor to condense. Okay, that means from vapor going back to liquid. Okay, and in state 5 you can see here pressure is to remain the same 1 atm, but the temperature rises to 300 degrees Celsius. Okay, so when the temperature start to rise, state 5 is now known as superheated vapor. Okay, so basically this will be the phase change process for any heating process. Okay, and we can transform our process into a TV diagram, okay, for our heating process of water at constant pressure. So inside our TV diagram, okay, you can see we plot our TV diagram start from our initial temperature, which is 20 degrees Celsius. Alright. Okay, going back to our slide, okay, at 20 degrees Celsius, okay, this is known as compressed liquid, okay, because the liquid is not about to vaporize, and you can see since heat is been supplied to our system continuously, the temperature now rises, okay, until it reaches 100 degrees Celsius. So when the first drop of liquid becomes vapor or start to vaporize, our state 2 is now known as saturated liquid. And then here you can see the line from state 2, okay, is maintained to our state 4, okay, meaning that during this process, okay, the liquid slowly turns into vapor. Alright, so this region is now known as saturated mixture, okay, and our point 4, meaning that the last drop of liquid becomes vapor or vaporized. Okay, so this will be the saturated vapor mixture, and then if we continue to supply heat to our system, the temperature will rise, okay, and you can see our point, okay, increases until 0.5 here, and this region is now known as superheated vapor. So if the entire process between state 1 and state 5 described in the figure is reversed by cooling the water while maintaining the pressure at the same value, the water will go back to state 1, retracing the same path, and in doing so, the amount of heat release will exactly match the amount of heat added during the heating process. Okay, so basically that is all, okay, for these topics. I see you again soon. Okay, thank you.